Generics. So these are the set of topics we are going to cover in this presentation. What is and why we want to use generics, and we will see examples of the usage of generics, and then we are going to create our own generic class. And there could be a situation where you have non-generic class, but you want to create generic method inside that non-generic class. So we'll see how you can do that. And we'll see the concept of subtyping in the context of generics. We'll learn the concept of wildcard and also bounded wildcard. There are two different types of bounded wildcard, upper bounded and lower bounded. So we're going to take a look at both. And we'll learn the concept of type erasure, and also we'll see how generic code can interoperate with non-generic code. What is generics and how to define generic class and how to use it and why use it? So what is generics? Generics provides parameterization of types. So classes and interfaces and methods can be parameterized by types. In the same way, type itself has been parameterized by an instance of it, for example. So this is what we are very familiar with. We define a method, for example, with a type of string, and then you have actual instances of the string. So when you call this my method, you can provide different instances, right? So in this case, type is parameterized by instances of the type. Now we are abstracting the type as well. So we are parameterizing the types. So this is an example. So this is an example of parameterization of the type. So we can define my method taking some kind of type. So we're going to say T and T. So this is a generic type. Now, when we call my method, we can provide a particular type. In this case, we could provide integer type or string type. Okay, so this is basically what I mean by parameterization of type. Now, why we want to use generics? Generics make type-safe code possible. What is a type-safe code? This is my definition. If the code compiles without any errors or warnings, then it must not raise any unexpected class cast exception during runtime. So type-safe code is guaranteed to work without class cast, a type exception, as long as it doesn't have any compile or warnings. Okay. Generics provide increased readability on types, so it shows type information. So once you get used to generics, it actually provides type information better than non-generic code. So let's see how we are going to define a generic class. We're going to take a look at a built-in class of a linked list. And this is the type parameter E. So if you take a look at the linked list source code in JDK, this is the code you're going to see. So linked list E, so it represents type parameter. So it represents the type of elements stored in the linked list. So in this case, E represents a type, not an instance. So internally, it's using E in various locations where a type is expected. So this is a definition of generic class, linked list E. This is from JDK. Now, once you have a generic class, then when you use it, you provide a particular type. So you could actually provide integer, string, or person type. So the usage is that you're going to replace this type parameter E, as you have seen in this definition of the linked list, with a particular type, such as integer, string, or my type, a person type, and things like that. Okay? So when you are using linked list with integer like this, what it means is that this linked list can only store only the integer or subtype of integer as elements. So in this code, we created linked list of integer, and then when we try to add integer, the first line, this should work fine. And when you actually try to get an item from the linked list, you don't have to cast it because it is already assumed as an integer type. Okay, so let's see an example of, again, definition of usage, a definition and usage of parameterized list interface. So if you take a look at the list definition of the JDK, you see again list is using type parameter E. Okay, so here you can see the add method is receiving E type, and also when you call iterator method, it returns iterator of E type. Okay, so this is a definition of a generic class. Then when you use that class, generic class, that time you provide a type argument. So it could be string, it could be integer, it could be my type. Okay, so in generic class, you have a definition of a class and then usage of a class. So definition should use type parameter such as this E, and then in usage, you're going to provide a particular type. Okay. So why generics? We're going to actually take a look at few advantages of using generics. Now, this is a case where we are not using generics. So this is a non-generic site, non-generic code, could cause a crash, type mismatch, runtime exception, and that is a big problem. So let's say we have a vector. Again, this is non-generic code. We have a vector, and it doesn't say anything about the type is maintaining. So we are going to add string type. And assume, as a programmer, I thought I was actually adding only string, right? But by mistake, I added integer object, and compiler doesn't detect it, right? So later on, I was trying to get the element as a string because that's what I thought I was actually, the adding. And but during runtime, it will cause class cast exception because when you're trying to get it as a string type, and obviously integer is not a type of string, so it will cause runtime exception. So having a runtime exception is really bad. Maybe you have an application running for 2 months without a problem, and then all of a sudden it crashes the system. So that's the thing that we like to avoid. So when you are using generics, these problems could be actually corrected. So these are the problems in non-generic code. When we are using in the case of collection. So compiler is unable to verify the type of the element. Assignment must have a type casting. And again, the biggest problem of all is class cast exception can occur during runtime. So these are the problems that we are going to solve with generic code. So generics tell the compiler the type of the collection element. So it will detect any type mismatch problem during compile time. So that is the biggest advantage of using generics, compile time detection of type mismatch problem. It let the compiler do the casting, meaning you don't have to do casting yourself because the compiler already knows the type of the elements in that collection. So compiler will check if you are adding integer type of entry to the string type of collection. So again, compile time detection of type mismatch is now possible when you write generic code, when you use generics in your code. Okay, so let's see usage of generics. So this is example 1. So here we are going to create array list object with a string type. So what that means is that this array list can only contain string type. So when you're trying to add integer object to this list of string, it will cause compile time error. So you should be able to detect this type mismatch problem during compile time. And when you add a string object, this is perfectly fine. And when you try to get the first element of the list, you don't have to cast it because compiler already knows the type of it. Okay. Example 2, generic class generic class can have, of course, multiple type parameters. In fact, the type could be your own type. So in this case, we have a hash map. The first type is going to be string, and the second value type is going to be mammal, which means that's my custom type. Okay? So when you add string object and then when you add mammal object, that's perfectly fine. So types are correct. So it should be fine. When you try to add a number as a first, the key to the hash map, then that will be detected at the compile time. Now, if you try to add any type here that is not a mammal or subtype of mammal, again, compiler will detect the problem. Here, when you get an object of the first, in this case, wombat key value, then it will return mammal. Again, you don't have to cast it because compiler already knows the type of the elements in this hash map. Okay, so let's do exercise 1. So in this case, we're going to just use generic classes, for type checking. So for those of you who are new to jpassion.com code camp, you have to download hands-on lab zip file. Again, if you go to over here, download this lab, okay, and then you just save it any place of your choice. So in my case, I have downloaded those zip file here, and you're gonna unzip it. So you're gonna actually unzip it like I'm using jar xpf command like this, okay, and it will unzip the hands-on lab zip file. And then you could actually read the lab documentation, but in this particular the hands-on lab, the lab documentation is not that much. I just actually clean things up because I actually put lots of exercises in the code itself. Okay, so basically what you have to do is you're going to actually import the project under samples maven directory. So you're going to actually import and make sure you expand Maven because these are all Maven project, and select existing Maven project and next, and you go to labs. In my case, you go to the directory that you have just unzipped. So here I'm going to go labs, and if you select the Java C generics directory that was just created, you want to just actually import samples Maven. Okay, and click OK, and I have already imported those things. Okay, so the first exercise is generics 01 type checking. So if you go over here, let's take a look at the code, main.java, and in this case, basically, we are going to just exercise type checking of the generics. Okay, so here we created array list of integers. So let me just expand this guy. And here, this one should work fine. Now, in this case, when you uncomment the code, then you should be experiencing this compile time detection of type mismatch. It says the method add int integer in the type of array blah 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 is not applicable for the argument int long. Okay, so it basically detected a type mismatch problem. Same thing with this code. All right, so you cannot. So this is accepting only integer as an element, so you cannot actually add long, string, or object. So these are all generating compile time error. This is the case that we are extracting the first element of integer, so this one should work fine, right? However, if you try to access it as a string, then this is a compile error because this one has to be integer type returned, and you cannot accept it. You cannot receive it as a string type. Okay. This is the case that we created array list of the strings. So obviously we should be able to add string object, but if you try to add integer or data object, then that should actually return compile error. Okay. In this case, we have array list of objects. So when you have array list of object, then you should be able to add pretty much any type of object, right? Okay. All right, so for your exercise, uncomment the code below and understand why some code generate compile error. Yeah, so basically, again, you can actually uncomment and see, if you understand why it doesn't work. It's pretty straightforward. Same thing with this guy. So this is actually a pretty simple exercise as long as you understand that genericized code provides some type checking at the compile time. That's basically the goal of this exercise. So I'm going to give you guys maybe about 10 minutes to try this exercise. And okay, so let's continue. So the example we have seen in our previous exercise was actually using the generic classes that are provided by the JDK, for example, list or array list and things like that. Now we are going to see how we can create our own generic class. So generic programming produces highly general and usable code. So like generic size collection classes, they are highly general and reusable, meaning you could use with any kind of type. So I want to write a sorting method which can sort items of any type. I want to write a display method which can print any type of object. Okay, so if you're not using generic code, if you're not using generics, then you have to actually write multiple maybe methods or classes that are specifically designed for that particular type. So this is an example. Suppose I have something integer class. So it does have, it maintains integer item, and then it has a set thing that takes the integer object. Okay. Now, if I want to create another class that maintains a string type, then I have to create another class like a something string. Okay? So in here, if I want to create an object from non-generic class, then I have to create an object, and then when I call that method, it will actually take only integer object, and it will cause a compile error when I try to set with the string objects. So if you're not using generic class, in order to have a type checking, you have to create a multiple classes or methods. Each of those are per particular type. Okay? So suppose, if I want to have another something long class that is actually maintaining only a long object, then I have to create a something long class with its own method. Okay? So obviously this is kind of too verbose. So we want to use generics. So with using generics, I create just a single generic class, then parameterize a type. So I'm going to create something generic class, which maintains a t-type internally. So it contains item of t-type, and I have a method that takes the t-types. So I create a single generic class, and then I should be able to provide particular type arguments. So if I want to maintain only integer type, then I say something generic integer, and then I should be able to use that generic class. And again, I have this type checking whenever I provide a different incorrect type, then compiler will check that out. Okay, so this is basically by using generics, we create a single class or a single method that maintains a type in generic way, and then when you use that generic class, then you provide a particular type. Does this make sense? So just compare the case where you do not use generics, and this is a case that you use generics. So by using generics, you are going to generalize basically the type by using type parameter, and when you use this generic class, at that time, you're going to provide a particular type. So if you're not using generics, here you have to actually create a multiple classes. Okay, each of those are designed for a particular type. So you can see the difference between generic class and non-generic class. Okay, so I want to write a type safe code. So suppose I want to create another class that maintains only long type. So if you're not using generics, then here you have to create a something long class. By using generics, only thing you have to do is you're going to use the still same generic class of something generic, and you provide a particular type when you use it. Okay, so the same something generic class will be used for various types. Okay. Okay, so type parameter naming convention. So as you can see, the way that you specify the type in the definition of generic class is you're going to use E or the something like this capital letter. So usually the convention is single uppercase letter for type parameters. Okay, so this is a convention because if you're not using this uppercase single letter type parameters, it would like a class or interface name. Okay, so recommended convention is E for element, K for key, N for number, T for type, V for value. So you could use just like S, U, V, or something like that. So this is just a convention. It's not mandatory. Okay, so let's do exercise 2. So let's take a look at the exercise 2, which is generics O2 class something generic. Okay, so open the main.java. So here is the case that you are going to create an object using non-generic class. So here I have something integer and something string. So if I want to create another one of something long, then I have to create another class. And this is a case that we are using something generic. So if you take a look at the something generic, okay, you see this code where we are defining generic code. So I specify the type of T, and internally I'm maintaining a thing of T type, and getThing method will return T as a return type. SetThing method will take a T as input argument. So pretty straightforward generic class. So in this case, basically by using generics, I specify particular type during the usage of generic class. Okay, so this is exactly what I showed you in the presentation. And in both cases, it does actually perform type checking during the compile time. So here it will check whether when you call the set method is actually setting with the type that you specify. Okay, so that's the compile time error. Okay, so for your exercise, create something generic to class, which has the following method. So you're going to have this method inside this something generic to class. So public void, so it looks like, yeah, so this one is duplicated. So public void display with new line, and you're receiving 2 arguments, and the first argument is generic type of U, and the other one is UV, and it will display U and then a new line and then V. Okay. And then I want you to create an instance of something generic to class and pass the test arguments to display with new line method. Okay. All right. So since this is the first time, we are doing exercise. The previous exercise, we just kind of take a look at the result by oncoming the code. This is time you're going to actually write the first time the real exercise. So I'm going to actually demonstrate it. Okay. So I'm going to create the something generic to class here. So let's say something generic to class and something generic to and new something generic. Yeah, I'm going to just copy this code. Okay, and since we do not have that code, we're going to actually create that class. Okay, and in our code, so what we said was in the main here, so I'm going to actually have the something generic to right here, and I'm going to maximize it. Okay, so what it says was it should have this public void display with new line, this method, which is actually taking 2 argument, which is U and V. So you're going to take a look at this code here. So it says multiple makers at the line, V cannot be resolver type, and U cannot be resolver types. So at this point, the compiler thinks that this is just like a regular type, like a person or something like that. But what we want in this case, U and V, is in fact the generic type parameters, right? So in the class, you have to specify U and V. So this is an indication to the compiler that U and V are not regular type. They are generic type. Okay. And then here, what we want to do is we're going to actually display, we're going to actually sys out you're gonna actually display the U first. Okay, so you're gonna say U. Okay, and then we are going to have new line like this, and then we are going to have V to be displayed. Okay, so we have the something generic 2 class with this U and V type parameters. Okay, now we should be able to use it in this case. All right, so something generic 2. Now you should be able to call display, and now we should be able to provide particular type of object. So in this case, we should be able to provide maybe new integer 2, and here maybe it's going to be string, new string object XYZ or something like that. And let's see whether this one works. Sometimes actually Alt Shift XJ sometimes doesn't work. Okay, so let me just try this guy. So here we are going to right click and run as and Java application. Okay, so it displays the 2 and XYZ. Okay, and you should be able to in this case pass a different type. Okay, different type in this case, you know, like long or not a long or something like that. So that's basically for your own exercise. So I'm going to give you guys about about 7 minutes to do this exercise. The recording. Yeah, so actually something that I didn't actually explain was that, the whole point of generic class is that I specify the type of it. So in this case, something generic 2, when I create the something generic 2 object, I specify the type. So integer and string, okay? And then when I pass integer object and string object, then it should actually do the type checking. Now, if I try to create, in this case, long, for example, I'm gonna try long here, okay? Then it's gonna have a compile error. Okay, so basically whenever I use the something generic class, I have to actually specify the type to take advantage of type checking of generics. Okay, that's something I missed it. Okay, so type reference inference. So from Java 8, type inference can be performed by compiler. So without using type reference, when you create an object of a particular type, so for example, if I'm creating array list of person, I specify both here and here. Okay. Now with Java 8, you don't have to. So basically, when you create array list, you don't have to specify person. So in our previous example here, I could actually specify integer and string, something like this. Okay, so that's perfectly fine. Okay, so that is allowed. I mean, that was the case before Java 8, but you can see these are in fact duplication, right? If the compiler can figure out the type by looking at here, why you have to actually specify the same thing over here, right? So from Java 8, this doesn't need to be specified because the type of this could be inferenced from here by the compiler. Okay, so that is a type inference. Okay, so now take a look at we're going to take a look at another example of creating your own generic class, part 2. So this is a case we have pair class, which is receiving two type which has a two type, F and S. And internally, you can specify this F and S type in any place where those types are, in fact, expected. So when you create your own generic class, you're going to specify whatever those generic type parameters using this sign of greater than and less than sign. Okay. So in this case, we are using two type parameters, F and S. Okay. When you're using those type internally within the class, you don't have to specify this greater than and less than sign. Okay, so you basically use those type in any place where a particular type is expected. Okay, so this is an example where we have created pair of number and string. So we specify particular type, and then we created pair object. Okay, by providing the actual argument. Okay, again, when you try to do these things, it's going to cause a compile error because you cannot actually specify the integer object as a second argument because it has to be string type. Okay, and here for P1 we set the long, and then second, again, these types should be actually detected based on the generic class definitions. You can actually extend generic class in the same way that you extend non-generic class. So here we have pair extended class, extending pair class, and here pair extending is adding another type. So in this case, F, S, and T. So T is actually being added. So extra method of pair extended, adding to pair, now it has field and method that is actually using extra type of T. Okay. You can actually use a generic class object as a type argument. Okay. So in this case, we have array list of integer object, and again we add 2 integer to this array list. Now suppose you have pair extended. So we actually define pair extended of number and string, and third argument is in fact the array list of integer. Then we have to actually pass array list of integer objects as the third argument. Okay? So if you take a look at the pair extended class here, the T could be anything. Anything that means that T argument could be the generic the class object. So in this case, array list of integer. So when you're trying to use this pair extended, if you're not passing array list of integer type, then it's going to cause compile time type mismatch compile error. Make sense? Okay, so let's actually see the exercise 3. Okay, so exercise 3 is pair I should have I made some modifications, and looks like for your own exercise. Oh, okay. Yeah, so it says a pair solution, but it is in fact the another solution. Okay, I think I have pair solution and the solution and non-pair solution as the same pom.xml file. Okay, so so the exercise is like this. If you take a look at the Maven, so let's just take a look at this code. Okay, so if you take a look at this code, this is the same code that you have seen in the slide. So we created pair object of number and string. So this one should work fine because we are assigning integer and the string object, and that's perfectly fine. It should work fine. And this one will actually cause a compile error because this cannot be integer object. It has to be string object, right? So if you do uncomment this guy, and then you're going to experience a compile error. Okay, all right. And now set internal variables of P. So we have a P1 object. So when you call set first and set second with correct the type, then it works fine. But if you try to use different type, then it's going to cause a compile error. Okay, so that's perfectly understandable. And then we created instance of pair fs and using wildcard. Yeah, so we haven't learned the wildcard yet. Okay, so don't worry about this part. Okay, so I want you to do your own for your own exercise. This guy and this guy. Okay, so for your exercise, create my class that contains the following 2 methods. So it will receive, it has the find number of occurrences. It will take list of T as a first argument, and then my item. Okay, so this code, you're gonna write code to detect how many times this item has been present in the list of this list of items. Okay, you're gonna have another method called the display pass item. Is actually receiving list of T-type items, and here you're gonna actually display each item in the list. Okay, and then you're gonna create an instance of my class, and then you're gonna invoke both of this, and using appropriate test data, try two different types such as integer and double. Does that make sense? All right, and then try to, so then you're gonna actually do this exercise. Create an instance of pair extended FST class with concrete type argument, number, string, and integer. And then you're gonna create an instance of it with array list of E as a third type of argument. So this is the example that I showed you in the presentation. Okay, so I'm gonna give you guys about 10 minutes to do this exercise. So far what we have learned is how to create our own generic class. So class level, you specify type parameters, okay, T, U, V, something like that. Now there could be a case where you have non-generic class. So the class level, you don't specify type parameters, but you might have a method that you want to genericize a method in that class. Okay? So generic methods are similar to generic class, but they are different only in one respect, that scope of type information is per method rather than class level. Okay? So generic methods are the methods that introduce their own type parameters. So this generic method is inside a non-generic class. Okay? So in this case, you can specify this generic type of T like this, and you have to specify this guy at a method level. Otherwise, this T will be considered as regular type. So to indicate to the compiler that these T are type parameters, then you have to actually specify this guy. So this indicates that the T is a type parameter. Without it, compiler will consider T as a regular type. Okay? This is required only when you have a method that is not in generic class. So this is a method that is generic size inside non-generic class. So we'll see example of that in exercise 4. So if you take a look at exercise 4, so we have actually two exercises. One is add item to collection. So let's take a look at the main class here. Okay. So this is an example where we are not using generics, and this is a case that we are using generics. So as we learned before, if you are not using generics, then you have to actually have a multiple method per type. So in this case, we have add person to collection, and so you are basically adding this person object to this people, the list object. And if you want to add fruit type, then you're going to have another method that add fruit to the collection. Okay, and now if you want to add animal to a collection, then you have to write another method. So that is the problem of non-generic code. In generic code, you're going to have a single method, add item to collection. In this case, if you take a look at this code, basically it's taking collection of T type, the parameter, and then it's going to take the element of T, and basically it will just call the add method of the collection object. Okay, and then in this case we are basically returning T. Now if you take a look at this code, we are inside the main, right? So main is not obviously a generic class. It doesn't have like its own T, something like this. It doesn't, right? So this is an example where we have a method that we want to make as generic size code. So this is a case of concrete. Yeah, so if you take a look at this guy, this is a concrete add person to collection, and it's actually specifying a particular person. This is another example of adding a fruit. So again, whenever you add to support, whenever you need to support a different type, then you have to write another method. By using generic type, you have a single add item to collection, and here you specify this type. Now, if you actually remove this T, if you have this remove T, you will experience a problem of T cannot be resolved to a type because the compiler thinks that this T is a regular type, like a person, right? So in order to let the compiler know that this T is a type parameter, then you have to specify this T at the method level. Okay. Same thing, we have another example of display result. So we are basically receiving list of T, and we are going to just display each item. So this is another example where we are generic size a particular method, display result. Okay. It can take any type, right? It could take any list of type. It could be list of person, or it could be list of the fruit, right? But again, if you miss this T notation here, it's gonna actually consider this T as a regular type. Okay, so you have to actually make sure for generic method, you have to have this T notation inside your on the method level. Now, if you actually make this guy as, if you say main class is a T, like this, T, okay, then you don't have to actually have this guy because T is now considered as the type, oh, wait a minute. Yeah, so in this case, cannot make a static, oh yeah, this is actually the static issue, not actually the type issue, okay? So when you have a type parameter at the class level, then you don't have to actually specify this T at the method level. Okay, so that is basically what this is all about. Okay, all right. So so that's actually the first exercise. So in this case, yeah, let me just remove this guy. So your exercise is create a static generic method that removes an item from a collection. Use people and fruit as a test collection. So in our generic method, we are just adding it, but the thing you're going to actually do is you're going to actually write another generic method. So remove item to collection, and then, so it's going to be exactly the same code, okay? But the name of the method is going to be different. In this case, you're going to actually use remove instead of add, all right? So that is pretty much what you're going to do. And I want you to use both people and fruits as the test collection, the item that you pass, okay? All right, so that is the first exercise. So that is relatively straightforward. And the next one is count all occurrences. So if you take a look at the code here, so again, we are using person and fruit as a test data, okay? So person array and the fruit arrays are provided, okay? So here, if you take a look at our generic code, so here, this is a method. That is generic size, so we have to have this T, because again, if you take a look at this main class, it is not generic class. It doesn't have its own T, right? Okay, so here we have the T at the method level, and basically we just kind of count how many times this particular item has occurred, and we should be able to call this method regardless of the type of the array that we are passing it, okay? Another example is that this is an example where we are using Java 8 stream, but since we have not learned streams, we don't actually have to, we're not going to talk about this one right now. It's just actually provided as a reference, okay? Okay, so in this case, for your own exercise, create a generic method that displays the name of the first entry of the pass collection. And again, I want you to test it with both person array and fruit array. And if you have time, try to create animal array and pass it to the method. Okay, so I'm going to give you guys about 10 minutes to try this exercise for the generic method. Yeah, so type inference is actually from Java 7 rather than Java 8. Okay, so thanks for the correction. So this is a case where we have a pair of FS and we have a two method, a constructor method and get second method, right? So if I want to actually make this one as a non-generic class, I have to just get this guy over here. And here maybe I could actually have something like this one as well, right? Okay. So this is kind of simplistic case where we have the generic method in a non-generic class. Okay, so if you actually remove this guy, that's not the example. If I remove this guy, then we have a problem. It's going to have a compile error. It thinks that the F and S are the regular type, right? That's the reason you have to have the F and S, something like this. Okay, all right. On. Next topic is subtyping. So generics and subtyping. So in pre-Java SE5, meaning before we are using generics, we were able to do these things. So we create integer object and we assign to object type. That's perfectly fine. And we could even create integer array object and assign to object array. So that's perfectly fine. So when we are using generic, we thought this could be possible. So we create array list of integer and assigning to array list of object. Okay, so this is not allowed. So in a sense, this is counterintuitive at the first glance. So let's see why this is not allowed. So let's take a look at that. So if you try to do that, you're going to have a compile error. Okay, and let's see why this is not allowed. The reason is because if it is allowed, then we are going to have type mismatch problem, meaning class cast exception could occur during runtime, which means that it has a possibility of non-type safe code. Okay, so let's see why that is not allowed. So, let's actually create array list of objects. So this is perfectly fine. The first line is fine. So we create array list of integer and we assign to array list the AI variable. That's perfectly fine. Now, suppose if we allow this. Suppose if you allow array list of object can receive array list of integer, then we should be able to assign this AI into AO, array list of objects. So if this is allowed, then this is certainly allowed, right? So now we add new object to the array list of object, and then when you try to get it, we try to get it to an integer type because this is allowed, right? So this will cause runtime class cast exception. So this is the reason why this is not allowed. Okay, on the second line, array list of object of is assigned with the array list of integer. So this is not, the reason it is not allowed is because of the fact that it could generate class, the cast exception during runtime. So the thing is that there is no inheritance relationship between type arguments. So there is no inheritance relationship, in this case, integer type argument with the, in this case, the integer type argument here and to integer type argument of object. There is no inheritance relationship between type arguments of a generic class. Okay? Okay. Now, generics and subtyping, this code still works. Now, this is fine, right? But between the classes, array list object can be assigned to a list of integer. So as long as type arguments are the same, this inheritance relationship still works. So this is what we used to know, right? Okay. And the same thing for array list object could be assigned to collection type, and vector could be assigned to collection type. Okay. So inheritance relationship between classes themselves still exists, and that is what we know of in all Java. So there is no backward compatibility problem. There is we are not breaking any existing behavior of Java by using generics. Okay, so inheritance relationship between classes themselves still work as expected. Now this code also works. So when we have array list of number, we should be able to add any number type object. So we should be able to add integer object, long object, but when you try to add string object, it's going to cause a compile error. Okay, so entries in a collection still maintain inheritance relationship. So as long as an item is a type of number or subtype of a number, such as integer and long, they should be able to be added to the collection of number type. Okay, so again, this is the behavior that we know of, and that behavior still works as expected. So there is no, the backward compatibility with existing or pre-Java SE 5 code. Okay, so let's do exercise 5. Exercise 5 is basically experiencing this subtype, issue here. So here, this is perfectly fine, and this is perfectly fine as well. This is perfectly fine because they all are the same type argument, right? However, if you try to assign array list of string to an object, this is a compile error, okay? Because of the reason I actually explained, okay? So if the Java allows this, then this will cause a possibility of runtime type mismatch problem, and that will, that is not type safe code. So if you take a look at this, type mismatch cannot convert array list of string to array list of object. So this is not allowed. Same thing of this guy, integer and object, okay? The type, there is no inheritance relationship between type argument, okay? So this integer and object, again, if you just uncomment, it's gonna be type mismatch compile time problem. Same thing with this guy, new array list of string, and now if you try to this, it's gonna be a compile error, okay? Yeah, and this is the same thing, right? Okay. So for your exercise, I just want you to uncomment this code and just experience a compile error, okay? And that's pretty much for this exercise. I'll give you maybe 2 or 3 minutes to do this exercise 5. Next topic is wildcard. So consider a problem of writing a method that prints out all the elements of a collection. So this is how we are going to write without using generics. So this is pre-Java SE 5 code. So we have a print collection method that takes the collection object, and we basically display each item in that collection. So pretty straightforward, right? Okay. Now, basically what we want to do is, even if you're using generics, we like to have a single method, okay, that takes any kind of collection type. So here we have a print collection method, and we say collection of object. So here we are going to actually create a collection of string, and then that is assigned with the array list of strings. So that's perfectly fine. Then we pass this collection of string object to this guy. Now it's going to cause a compile error. In the same way, it's going to cause a compile error on this line. So if you try to assign array list of string to array list of a collection of object, this is not allowed because there is no inheritance relationship between type argument, string, and the object here, right? And the same reason, we cannot really pass array list of integer to the collection of object like this, to this method. So we have a problem. We want to create a single print collection method that takes any kind of collection of a particular type, but we cannot use collection of object, unfortunately, because of the reasons that we just talked about in previous slides, right? So how can we solve this? We do not want to have multiple print collection method, but taking a collection of a particular type, like a string or integer, long, person, and things like that. We probably have to write millions of print collection method, taking care of the type that is being passed. Okay, so that's not good. So we need to have a better solution. So that is wildcard. So wildcard is basically this question mark. So collection of this question mark means collection of unknown type. Then it will take any type of you passed. So we are going to create one single print collection method that's taking collection of question, meaning collection of unknown type, and we have to access it as object type, okay? So in this case, when we pass array list of string or array list of integer to this print collection that taking as a collection of unknown type, the compiler will not complain about it. So this is the way that you can actually have a single print collection method that can take any type of collection of type, particular type. Okay, so this is wildcard. Okay, by the way, you cannot access entries of a collection of unknown type other than object type, because this code doesn't really know what type it is. It could be, in fact, a string type. It could be integer type, right? So you cannot really use it as a particular type. It always has to be object type. Okay, so if you try to access it as a string type, it's going to be a compile error, because this code simply doesn't know. Compiler simply does not guarantee the type of this guy other than it's an object type. Okay, which is the type of every type in Java. Okay, so that is the wildcard. Now, there is a concept of bounded wildcard. So, in fact, there are two different types of bounded wildcard. One is called the upper bounded wildcard, and the other one is called lower bounded wildcard. Upper bounded wildcard, you can specify using extend. So here you can say question mark extends number. The reason it's called the upper bounded wildcard in this case is that the number is basically top of the class hierarchy. So the type that is being passed has to be the number type or a subtype. So in this example here, you could actually create array list of number and assign to list of unknown type extends number, or it could be integer type, or it could be number type. Okay, if you try to assign array list of string, then it's going to be a compile error. As long as the argument type is a number type or a subtype, this is going to be fine as far as compiling is concerned. Okay, so just to rephrase what upper bound wildcard is all about. Upper bounded wildcard restricts the unknown type to be a specific type or subtype of the type, and is represented by using extends keyword. Okay, so it should be number, integer, double in this example. Okay, lower bound is the other way. It's called the lower bound in this case is because in this case the number is the bottom of class hierarchy. So any type that you pass is supposed to be number type or pattern type of number, super type of number. So this is allowed array list of number to unknown type super number, and array list of object assigned to a list of the unknown type super number. So this is lower bounded wildcard. This is upper bounded wildcard. Okay. Now, what is the implication of this lower bounded and upper bounded wildcard? So let's talk about the upper bounded wildcard. Okay. So upper bounded wildcard, you can read the item, but you cannot write. What that means is that you cannot add any object to the list of extends T because you cannot guarantee what kind of list it is pointing to. So you cannot guarantee that object is allowed in the list. So the only guarantee is that you can only read it and you will get a T or subclass of T. So let's explain what this is all about by using an example. As I said, this code here is allowed. These are all safe, type safe code. So here, foo could actually pointing to array list of the number. It could actually pointing to array list of integer. It could actually pointing to array list of double. Okay. Now, if you try to add integer object to this guy, that's going to actually compile error. So here it's going to cause a compile error because you cannot add, in this case, integer to foo because a foo might be pointing to list of double, right? You are actually adding it as integer, but it might be pointing to list of double. So that possibility prevents basically because of that reason, adding an item to this upper bounded wildcard collection object is not allowed. Okay, same thing here. If I try to add a double to a foo, the foo might be actually pointing to list of integer. Okay, so that's the reason behind the reason why it is not allowed to write into upper bounded wildcard collection object. But you can read. So you can read foo.get1, and you should be able to read into an object type. Okay, actually number type. I should actually say number. The XYZ equal foo.get. Okay, so you can read into the type of number, but you cannot write. Okay, so that is upper bounded wildcard. And lower bounded wildcard is the opposite. You can write, but you cannot read. Okay, the reason is because you cannot read the specific type T from the list of the unknown type super T, because you can't guarantee what kind of list it is really pointing to. The only guarantee is that you can write, you are able to add a value of type T without violating the integrity of the list being pointing to. So here, foo could be pointing to array list of number, or it could be pointing to array list of object. Okay, because so here you could actually add integer object or double object. Okay, as long as these are the type of number. Okay. In this case, but you cannot actually read into a specific type like a number. Okay, but you can read it into object type, because everybody is in fact the object type. Okay, all right. So let's do exercise 6. So let's take a look at the wildcard example first. We have 2 examples. So main Java here. So this is example code that I just used in the slide. We have a print collection of object. Okay, and here we have created list of integer. Now if I try to call this guy, it's going to be a compile error, because you cannot assign list of integer object to the collection of object. Okay, this is no, right? Okay, so this is not allowed. Okay, so basically your exercise is, I want to actually modify this code so that it's using wildcard. Okay, I mean, this is too straightforward. Basically you're going to use the question mark here, and then it should work fine. Okay, all right, so that is the exercise. The next one is using bounded wildcard. Okay, so here let's take a look at the here. So this is the usage of upper bounded wildcard, and this is using lower bounded wildcard. Okay, so here if you try to write, then it's going to be a compile error. So in upper bounded wildcard, writing is disabled. Okay, but here you can read it. So you should be able to read it in this case, number x equals something like this. Okay, so yeah, that should be something I should say. So you should be able to read the number type. Okay, and lower bounded here, you should be able to write. You can add it, but you should be able to. You are not allowed to read it. Okay, so you cannot read it into number type. However, you should be able to read it as object type, because everybody is object type. Okay, all right. So I'm going to give you guys about 5 minutes to try this the wildcard and wildcard bounded exercise. Okay, so let's talk about the raw type and type erasure. So what is a raw type? Raw type is a code that does not use generic. Okay, so generic type instantiated with no type arguments. And basically, the pre-Java SC5 library code still should work with generic code, right? Okay. So if you write code that doesn't use generic, then compiler will generate a warning message. So here, this is the example where we are in fact using generics, right? So we say it's a linked list of string type, okay? However, if you try to create a list object of linked list, without using generics, so this is called the raw type. So raw type is a code that does not use generic, okay? And of course, you should be able to use both, right? However, if you try to use code that doesn't use generics, the compiler, Java SC5 and after compiler will give you a warning. Okay, so give you a warning to make sure that you know what you're doing. right? So that's the reason I say in the beginning of this presentation that type-safe code is the code that does not have a compiler error and it doesn't have a warnings, okay? Okay, now let's talk about the concept of type erasure. Type erasure means that any generic type information is removed from the bytecode. So as I said in the Q&A, generics is only for compiler. Okay, so once the code is compiled, any generic information is in fact removed. Okay, so any generic type information does not exist during runtime. So after compilation, they all share the same class object. So whether you have array list of string or array list of integer, once they are compiled, okay, they're actually pointing to the same class object of array list. So generics is only for compile time thing. It has nothing to do during runtime. Okay? Okay, so this is a simple example code that we actually see in an array list of integer and array list of string. Once they are compiled and once they are running in the runtime, they are in fact pointing to the same array list object. So here we have array list of integer object AI, and we have array list of string AS. Okay, during runtime, we're going to actually compare class object of AI and class object of AS, right? And they should be the same class object. So here, it should return true. Okay, so they are not two different array list class object. They are pointing to the same array list object. Okay, right. So as I said before, type-safe code. Compiler guarantees that either the code it generates will be type correct at runtime or it will opt the warning. So if you have a raw code that doesn't use generics, it should give you at least a warning, okay? And of course, there could be a case that if you disregard a warning, then you could in fact still experience runtime type exception, and that's something we're gonna actually play around in the lab. So if your code compiles without any warnings, okay, then you will never get type mismatch exception during runtime. That is a type-safe code. Okay. All right, so let's do exercise 7. So exercise 7, we are basically playing around with a type erasure. So here we have this code. So we have array list of integer, okay, and then we have array list of string, okay. And we are basically displaying class object, okay? And also we are checking whether the class object of array list of integer and array list of string, in fact, is the same thing. It should return true. Because during runtime, there is only one single array list, the class object, okay? So again, this type information in generics is only for compiler, okay? After compilation, bytecode doesn't contain any generic related information. Okay. So here we basically check if two array list instances with a different type parameters, it should actually return the same. And this one, check if two array list instances with different type parameters, one with the integer and the other one is the raw type. Oh, so raw type. Okay. Again, raw type should result in the same class object. So let's run this guy. Yeah, so it should actually return at the end true and true. Okay. All right, so that is basically this exercise. There is nothing much to do, in this exercise. I just run the code and see it's behaving as expected. Okay. All right, so the class object is basically there is a Java util.ArrayList object. There is no separate Java util.array list of integer or array list of string kind of object during runtime. That's basically the point of this exercise. Okay, so I'm going to give you guys about 2 minutes to try this run, the code, and as long as you understand the concept of type erasure, that should be good enough. Okay. The last topic is interoperability with non-generic code. So you should be able to have code that uses generics, and then the code that doesn't use generics. They all should work. Okay, because we do not want to break the backward compatibility. There are tons of code out there, libraries that are written before Java SE5 that do not use generics, and you should be able to use those code. Okay, so let's take a look at an example. So we have the generics interoperability class inside the main. This line, the first line, this is using generics. So we are creating linked list of string type. However, the next line is not using generics. So this is the raw, the type. Okay, here you're going to actually experience the warning. The compiler should give a warning here. Now, when we add this raw type, we actually add integer. It's not going to cause a compiler error, right? Okay, so when you run it, then you're going to actually have a problem. You know, this is going to actually cause runtime type mismatch problem. Okay, but compiler at least should give you a warning on this line, list raw, and you know, when you're assigning list of string into a list of raw type. Okay, so that is basically compilation and warning. Compilation result in a warning message. Okay, and when you run the code, it will in fact cause runtime type mismatch problem, you know, class cast exception. Okay, so that is exercise 8. So if you take a look at exercise 8, let's take a look at the code. That is pretty much what I showed you. Okay, so now let's take a look at the warning message. So this has a warning. So if you take a look at this warning, list is a raw type. References to generic type E should be parameterized. Okay, so you know, this at least the compiler give you a warning. So in this case, we ignore the warning, so we add the string integer object to this type, right? And first of all, you know, so basically assign the list of string to this raw type, right? And then we are able to actually add integer object, okay? And compiler doesn't know anything about it because we are dealing with the raw type, right? Okay. And then we are basically trying to get it from you know, into again, this case, we're trying to add so this we are using in the generics type. Okay, so this is fine, right? So basically, we are gonna actually experience a problem of runtime type mismatch problem. Okay, so let's actually run this guy. Okay, so you can see class cast exception on number 16. So when you try to get it, internally it's in fact the integer object, right? But you're trying to get it as a string object, okay? And so this is an example where when you ignore a warning message from the compiler, you could still experience runtime type mismatch problem. So you really want to make sure that this line is in fact benign, right? Okay, so you know what you're doing. So that's basically this exercise all about. Okay, so I'll give you a few minutes to try this exercise and we're gonna move on to Lambda. Okay.